Can you see my screen? Can you see my screen?
It's loading, ma'am.
It's loading.
Yes,
Yeah.
ma'am.
So we are in second unit or third unit? Hello?
Second, ma'am.
Second unit.
ma'am.
Second. Okay. Second unit, we have the stacks and queues and the last topic, that is a linked list topic. So today just I'll give the introduction what is meant by linked list. Okay. So what is the difference between arrays as well as a linked list? So till now we used as a stack is only one side you can insert as well as you can delete the data. In a queues, there are different types of queues are there. Normally one end we can insert and another end you can delete the data. One end you can insert, another end you can delete the data. And queues and dequeues combination means only two ways you have the insert and delete will be there. Only one side you have the insertion will be there. Okay, dequeue as well as enqueue, priority queues. These are the different types of queues are there. So arrays and linked list are examples for the linear list. So whenever we are going for the linear list, what are the linear list means arrays and linked list are the examples for your linear list. So whenever you are going for any linear list, whenever we are not saying linked list, we are saying a linear list. Linear list are those in which each member has a unique successor. Each member has a unique successor. Successor means before or after?
After, ma'am.
After. So after one you have one element, after you have one more element. For this you have one more element, you have the one more. Suppose example, whenever you are using this arrays, arrays what will be there? Suppose example, whenever we are dealing with, suppose the elements are there. So this is a, you have the successor, there will be another element will be there. This will be another element, this will be another element, this will be another element, this will be another element. So assume that you have storing the integer values. Getting idea? You are storing an integer values. The address is taking 8000. Address is taking 8000 and 8002. 8002. You have the second element like this. Like this 8004, 8005 will be there. So arrays contains the consecutive memory location. So each that is a fixed distance apart, where linked list does not necessarily contain the consecutive memory location. The first difference is whenever you are saying an array, it is a consecutive fixed distance. So suppose first one. Now go on mute somebody. Okay. Array contains consecutive memory location, that is a fixed apart, whereas the linked list does not necessarily contain the consecutive memory location. So when you observe this 6 and 67, 98, whatever the data is there, and it is starting with 8000, 8002, 8004, 8006, 8008, 8010. Means we given a fixed like this. But whenever you are going for the linked list, it is not like this. Some memory location is free, it will be occupying the first element. Another some memory location is free, it will be occupying. It is not a continuation memory. It is not a continuation memory in linked list, but an array, it is a continuation apart. These data items can be stored anywhere in the memory in a scattered manner. Anywhere in the memory, it is in a scattered manner. So to maintain a specific sequence of these data items, we need to maintain a link with a successor and a predecessor. It may be a successor will be there, or it may be the predecessor will be there. Okay, it is called a linked list. So whenever you are going for the linked list, it may be for data you have the successor will be there, or it may be the predecessor will be there. For arrays, only the successor will be there. You have a starting point, and next will go. But whenever you are going for the linked list, you have the both predecessor will be there as well as the successor will be there. It is called a linked list, with each node is linked with its successor or it will be the predecessor. So whenever we are saying a linked list, so we will be representing in the form of this is your data and this is your address. For whenever you are going for the linked list, it consisting of a node. It is a node will say. This is called a node. For node, you have more data is there, means more nodes will be added to this one. Okay. Suppose what is a node? It consisting of a data as well as address of another node. What is a node consisting of? Node consisting of data. We are saying here it is not address. We will say the link of the another node here. Suppose consider I am storing a data. This I am storing 34 is my data. It is storing in 8000 location. Where I am saying 8000 location. This assumes that the memory started with 6. Okay. Now, whenever I want to add one more element to this one, I can say I am taking 55 is my data. Okay. Now this is your 8000. This is your 4.67. So next time I am storing one more data here. Just I'll copy. Yes, ma'am. Yes, ma'am.
Ma'am.
Yes, ma'am. Tell me.
Ma'am, your voice is not clear and the screen is not visible, ma'am.
Visible. 1 minute. I'll increase the size first.
Your voice is not clear, ma'am.
Once again, I will.
And the screen is not visible.
Now you can see the screen.
Yes,
now you can see. Yes. Okay. I'll go for here. Can you listen my voice properly?
Yes, ma'am. Yes, ma'am.
Yes. Okay. Now, if you observe this one data and link, I told you it is a node. Okay. 34 is my data. It is storing in 6000 memory location, and the next node is in 8000. In 8000, you are storing as a 55, and I am using another 4567 is my 4567 is my this is address. And this is the value. I can say this is number. Now, how many data elements are there in this? Anybody can say?
3.
What are the data? 3. What are the data we stored here?
34, 55,
554. Okay. 34, 55 and 554 it is there. So, suppose the same data if I want to store in array, what will be what you can see like this. So I need 3 data here. One is 34.
34.
The next one is 55. Next one is 5554. Okay. So it is, whenever you are storing in this array, this is the concept. You are storing the data in the form of like. But if you know only the starting address of this array is enough. So for this, whenever you are going for the linked list, how you will be using the small example. The example I am saying. If it is not compulsory. It has to store in 8000. Depending on the operating system, operating system will assign the address of this one next node. So this is my data. This is the link. Suppose whenever I want to first head, this is first, whatever the first one, it is called head. Head means starting address of a particular linked list. What is the head here? Starting address of the particular list. So once I know the address of the first node, then automatically I can traverse to the second node. How? Using this link. Link is 8000. So wherever the link 8000 location is there, from 8000 location I can take the value. I can take the data here 55. So next I want to go for traverse, means I can go to take the address of this one 4567, and 4567 there is a data is there 554, and there will be a null, means what is the mean by null? So there is no elements are there.
Zero.
There is no elements. Address is not there, means only you are ending with your linked list, I can say. So in the previously, whenever you are normally to refer this book, sometimes previously some years back will be, so you go to the particular page 20, so there will be one hint will be there. From the hint, okay, go to the another page 120. So in the 120 there will be another page. Okay, so you got this something. We can play like this. So here also the concept is here. 6000, once I know the address of the particular first node of a linked list, I can traverse. This is what I can traverse. Traversing means visiting each and every node. What is meant by traversing? Visiting each node.
And every node.
Yeah, suppose in this also, arrays also there is a traversing is there, means first I know the 34, then automatically +1 or +2 add, it will go to the 55, and I can reach to the 554. When will be the stop here in array? Whenever it is reaching the maximum element, it will stop here. But when will the linked list will stop? Wherever the last address will be the null, it is the end of the your linked list. End of the linked list. So what is the linked list means? You can add an element, you can delete an element, you can traverse an element, you can insert element, okay, and you can traverse in both. Whenever we are dealing with the types of linked list, I'll say both addresses will be there, before and after will be there, and you can join one link with another link. You can sort the link, you can merge the link. So what are the operations performed on a link? What are the operations performed on a link means? The first one is inserting, and you can delete an element very easily. Delete, and you can traverse. You can traverse means visiting each and every node. We can join, merge with one node with another, one list with merging list, we can say. And fifth is you can sort the list. And sixth is merging, sorting, traversing, deleting. Yeah. This one you can do the processing, merging, sorting. Search a list also you can do. If you want to search an element, you can use a search. So what are the operations? Is inserting, you can
Delete.
Deleting.
Traversing.
Traversing means visiting each and every element. Merging means adding one list with another list. Sorting means it will be arranged in the numbers or arranged in alphabetical order. And you can search means if you want to search an element, you can search in a linked list. You can the same thing you can do in arrays also, but in this whatever the movement, what is shifting from one place to another place, it will be reduced in your linked list compared to your arrays. Arrays are static. Static means the size will not be increased. But linked list, you can add any number of elements to this one. And deleting is simple. When you are changing the address, only the changing of address from one list with another, one node with another one node, it will be deleting. And you can traverse, merge means you can add one list with another list. Already you have the 100 elements, you have one more element. If you want to club means, only the addresses for last address will be changed to the first address of the another list you can go. So we'll be going one topic in detail here. So what is a node? Node consisting of data as well as a link will be there.
Data
and link is nothing but here address of the successor. Address of the successor. Suppose I want to join, I want to add one more element. What I can do? What are the changes here? Tell me. Suppose I want to add 60 elements. I want to add 60. What are the changes here? My list. So, what I have to do? 60 I have to increase here. Okay. And what is the address for this one? Previous node address?
4562.
This is now my address is 9000. Means it is allocated a memory for this one 9000. Where are the changes I have to make?
In the address of 554.
In the null address I have to change to
9000.
9. Suppose one more add I want to do. Suppose in this my next address is this one. So here I am storing 5. So what are the changes here?
In null place we have to
8, 7. Now if you observe this one, your 800 is a dot, it will be coming inside. Okay, so my data is first node I'll be storing as a 34, next node I'll be storing as a 55, next is 554, next is 60 and 5. Suppose I want to remove an element 55. I want to delete. What are the changes I have to make here? Now you have 34, 55, 554, 60 and 5 is there. What will be the changes here means? The address of the next, whatever the next, the link, if I copy here, it will be removed. Just check it. 8000, no? Whenever I use 4, 5, 6, 7. So now the 34 is your data. Now how it will be traversing, just you go to 34 is my data. What is the next address? 4, 5, 6, 7. 4, 5, 6, 7, this is your data. 4, 5, 6, 7 is 554, and there will be a 60 and there will be a 5. Now see, 34, your address is 4, 5, 6, 7. So it is not going to 8000, it is going to 4, 5, 6, 7. There is a 554 and there is 9000. Once again it come here, it will be taking the 60 value, and 8766 is the other address, it will be going for the 5. Now this is, I deleted the, only what I changes here. The next element is, whatever you want to delete, you have to traverse till the particular element. You take the address of the link of this one. If you go to the previous one address, if you change, automatically this element will be removed here. This is for deletion. This is for deletion. So in between I want to add a element. In between I want to add a element. What are the changes here I have to made here? 1 minute. So assume that our address is, I want to, 76 is my data. It is storing in 4534. What are the changes I have to make? Between this one I want to add. So I have to reach to 554 here. So what are the changes here? This 9000 will come here. And this 4534 will come here. Now if we traverse here, 34, 4567, 554, 4534, it will go to the 76, 9000 this is 60, and 8066 is 5. So you can insert, but by changing only the address of the link. If you are changing, automatically you can add an element beginning or end or in the middle also you can do. So this is very, so whatever the transaction, whatever the movements, it will be less compared to your arrays. And how many elements you want, you can add here. Is this clear, ma? Shall I repeat once again? Is it clear? Shall I repeat once again?
Once again, ma'am.
1 second. Okay. I will remove
Element, ma'am.
Yeah, ma'am.
Element will be deleted from the last or from the middle also you can delete, ma'am.
That's right. Middle also you can delete. I'll show you one example here. So
Okay, ma'am.
write down I want to go for this box here, insert of 30. For this also I'll give the address. Assume that it is 5000. Insert of 56. This is the 5000 is address. 5700. Example I am telling. Insert of 45. You write down this on your paper.
Okay,
Please,
ma'am.
Everybody has to write down these boxes. How many boxes you need here?
4.
Oh. My head address is
5,000.
now draw the 30, 56, 45, 90, 12. Actually, side by side you write. I am not getting side by side. That's why I am writing 5 elements here. Side by side you write it.
Okay.
What is the first one?
5,000.
First one is
30.
element.
30, ma'am.
30, ma'am.
Everybody wrote, ma? Please.
Yes, ma'am. Yes, ma'am.
First is the 30. Now 30. What is the address here? 5,000 is, sorry, 30 here.
5,000.
5,000. 5,000 is my address. Okay.
Next address.
What is the next element?
56.
And it is 5,000, 5,700.
700.
Here,
Next element.
the previous, this 56 we have to store here. This address has to be changed here. Okay.
5,000. Yes, ma'am.
Next time it will be, the null will be there.
5,007.
You are adding 45. I am creating is a 45 here. What is the address here? 45 6758.
67588.
67. Okay. 67588. Okay. And this will be a null will be there whenever you are adding first time. But this address is changed to 67588.
588.
Yeah. Next address is
Next
90.
address 90.
90. This address is, what is the address?
7676.
7676.
76.
But this you have to change to 7676.
7676.
It will be the null. Now, next is
12, ma'am.
12.
12. So we'll be writing 12 here. What is the address for this one?
2000.
2000.
2000. Now, this 2000 has to change to here. Okay.
2000.
And this is null.
Null.
And down is null.
5,000 is your header. Getting idea? 5,000 is your header. Header is
Yes,
5,000. 37, 5,007. You'll go to the wherever the location is at 5,000. It will take the 56. It takes you once again 6788. It takes you the 45. 76766. It will takes you the 90. And it will take you the 12. Whenever it is reaching the null, it will stop your traversing. This is called traversing. Got it?
Yes, ma'am.
So you can insert.
What, ma'am?
You can insert elements 3 ways. 3 ways you can insert an element. First is position sampling. In a starting position, in a ending position, or in the middle, you can middle or any location you can see. Suppose I want to insert before 30. What I am doing in insert before, not insert, insert beginning. Insert beginning. I want insert beginning. My element is 78. It is the 8976 is my address. 78 is my data. 765856 is my address. So where I have to insert what are the changes I made here. I want to make. What are the changes here I want to make here? Suppose I am creating one more node here.
78.
What ma? This is a 78 will be there. And this has the address 7656 is my address.
And 5,000 is another one. 5,000.
1 minute. Okay. Now before 30 you are inserting. So this 5,000 will come to here. Yes or no?
Yes, ma'am.
And header will be changes to
75.
76. Is it clear? Is it clear?
Yes.
Clear, ma'am.
Yes, ma'am.
Yes,
Now,
ma'am.
Ma'am, repeat once again, ma'am.
once again I am showing. Insert
ma'am.
beginning. I want to insert one more element beginning. That is my element is 1. It is taking 4321. Address is 4321. So automatically what will do here? It will be adding one more element here somewhere. Anywhere you can add element. Sorry, this one. This I am taking as this one as copy here. Here it is a paste. And what is the value for this one?
1.
What is the 1? 1. And what is the address? My stop chain mark, please.
4323.
Go
323.
on mute. Go on mute. It is disturbing others also, no? Insert beginning of 4323. So the address will be 4323 and you already given 1. But what are the changes here? I have to make before 78 you have to use. What is the 78 address?
7656. 7656.
So now this address is 7656 I have to add and header has to change to 4323. Is it clear? Adding in the beginning.
Yes, ma'am.
Yes, ma'am.
It's okay, ma?
Yes, ma'am.
Yes, sir? Okay. This is the one.
Yes, ma'am.
Okay. Next I want to add the element in the last. What are I have to do? What? I have to I have to allocate these elements here. Assume that it is in my element is 23 and this address is 2000. And what are the changes I have to make here?
In the null place, 2000 replace, ma'am.
In the null place, you have to replace with 2. Okay. So what are the elements are there in this? Anybody can say here? What are the elements? The first is traverse. 1. 755. Well, it will go to the 30.
And 56, 45, 90, 12.
12 and 23. These are the elements. Elements. Okay. Now, I have to add element after 45.
Excuse me, ma'am.
Yes, ma'am?
Ma'am, last element address is 2000 again, ma'am. Last two elements.
Yeah. Is it okay? Okay. Now,
Yes, ma'am.
Means by seeing this one diagram, you can insert in the front or you can insert the element after last one. Last also you can add and beginning also you can add. So there is two options are there. After which element you want before or after also you can add one. Suppose I want my wish is I want to add an element after 78. After 78 I want to add one more element. What I have to do? I have to take my header. What is my header? What is my header value? 4323. 4323. 2323 or 4323?
4323, ma'am.
Yeah. So I am going to 4323. I am taking the value called 1. In the 4333, what is the data value? 1.
1,
so
ma'am.
1 equal to 78? No.
No, ma'am.
So it will go to the, it will take you the 7656 value and it will be go to the particular element. 78 equal to 78?
Yes, ma'am. Yes, ma'am.
So after means I am telling after. So for 78 equal to 78, whenever it is reaching a particular one, here it will be allocating a memory for this one. This one. So it will be allocating a memory for this one after 78 with some location. 66 is my data and first time it will be the null will be there. What are the changes I have to make here? Anybody can tell?
In the play, 66 address is 5000.
I have to give 66 address, no? This is 5000 is the already previous one. It will be allocating 4321 is my data. 4321 address is there anywhere?
No, ma'am.
No. So it will be allocating whenever it is creating a new node, it will allocate a different memory location. What are the changes I have to make here? 3 places you have to change. One is wherever the 5000 is address is there, no? It will be changes to 4328 and this address is changed to
5000.
That is inserting. This is inserting after. This is inserting after. Now if we observe this one, 1 and 78, 66, 30, 56, 45, 90 and 12 and 26. These are the data. Okay. This is to insert the data. This is to insert the data, insert beginning, insert end, insert the element before, insert after also you can use. Insert after also you can add the element. Suppose I want to remove 67. Deletion. Deletion also same thing. Deletion, front, deletion and deletion of the particular element also. Suppose I want to delete the first element. What is the first element address? 1 and this. 7656 is there. The header address is
4323 is the address.
The header will be 4323. This one address link is 7656. I want to remove this means whenever this 7656 no, if I change the address 7656, so automatically what is the header address here? 7656. It will take you 78, 66, 30, 54. So if you want to remove the elements in the beginning, what you can do? Change the address of the header automatically. It will be means first node of the address. This one. First node of the address. If you change to the header, automatically it will be remove the first header. Suppose in the last element I want to remove. What I have to do? For this element, what is the previous address? For this 23, what is the previous one? 2006. 12 no. So this 12 address, if we change to null, if we change to the null, automatically the last element will be removed. Yes or no?
Yes, ma'am.
Yes, ma'am.
Now this element will be removed here. This element is removed and this element also removed. Okay. This is deletion. Now if you observe this one, but somebody go on mute, ma, please. Now if you observe this one, header is the 4800 and there is a 10 element is there, 4900. You are pointing to this one, this is a 15 and 4900 this is address and this address is 5000, it is going to this one and this is the 2000. Suppose I want to remove 5. What are the changes I have to make here? What are the changes I have to make here? This 5000 whenever for the next whatever you are reaching to the 5000, if you are reaching the 3000 to here, so automatically 4800, the address is 4900 and another is that is 3000, so it will go to the directly to that value. So 10, 15, 20 will be there. Okay, this is a simple list. You have the header is there. Tomorrow will be once again like examples, member. This is also an element. Monday, Tuesday, Wednesday, Thursday, Friday and Saturday. And you can add an element here. So tomorrow will be continuation with one more.
And
topic. Same topic only will be continuing in the next class. Okay. Yes, ma'am. Thank you, ma.
Okay, ma'am.
Thank you, ma'am.
Okay, ma'am. Thank you.
Thank you,
Send
ma'am.
address. Send attendance.
Okay, ma'am. Thanks.
చెయ్యాలి. అరే మాకేమో ఫ్యాన్లు కావాలి.